G'day, today we begin our discussion of trigonometry, and before we can define trigonometric functions, we need to talk about what we mean by an angle and how we measure angles. So essentially an angle is just formed by two rays, two straight lines. The rays we think of as emanating from a particular vertex. Here's the vertex here, that's just the point. And then the rays are these directed lines, and the angle is formed between those two rays, and we give those rays names. We're measuring the angle from the initial side to the terminal side. So this ray up here is the terminal side, down here is the initial side, and the angle is measured from the initial to the terminal side. While that's a nice abstract definition of an angle, most of the time we're working on the Cartesian plane, so we measure angles in the standard position. And the standard position is literally putting the initial side along the x-axis. And with the initial side on the x-axis, we're then measuring our angle, let's call it theta. We're measuring our angle from the initial side, which is just the positive x-axis, to the terminal side, and we always measure a positive angle in the counterclockwise direction. So against the direction of the clock. So to be able to begin formalizing what we mean by angles, we're going to begin by defining the idea of degrees. One full counterclockwise rotation is defined to be 360 degrees. And so you see on this picture, if I start at a point and I rotate entirely around one full counterclockwise rotation, that is 360 degrees. So starting from here and going once around the entire plane, that is a 360 degree rotation, and we write degrees with the little degree symbol up there, or you spell out the word degrees, but we need to put the units on it. All right, so that means we can define lesser rotations. For example, 90 degrees is 1/4 of a rotation. 90 degrees is going to take you this far. So there's a 90 degree rotation. And I'm just going to start writing them here. This is 0 degrees. So 90 degrees takes us 1/4 of the way. 180 degrees takes us half the way around. Then we add another 90, that's 270 degrees, takes us 3/4 of the way. And then all the way around is 360 degrees. And so we're back where we started. And so in a sense, 360 degrees and 0 degrees are describing the same point. And so we need a name for that, and those angles are called coterminal. So here's an example. I've marked here an angle that I intended to be 1/8 of a rotation, so 45 degrees. Remember, 90 degrees takes us to the y-axis from the initial side. In standard position, I'm always going to work in standard position unless we say otherwise. So that means the initial side is along the positive x-axis, and we're measuring counterclockwise from there. So here's a 45 degree angle with the terminal side up here. You could equally well imagine that I start here and do a rotation to essentially the same point, but going counterclockwise. So this rotation is in the other direction, and so we can think of it as going -90, -180, -270 degrees, and then we're going 45 degrees further in the opposite direction, so that's -300 and what's that, 15 degrees. And so this terminal side here, there's a terminal side, and they're both the same. My point here is that I could have talked about going 45 degrees in the clockwise direction, and the counterclockwise direction, and so that's 1/8 of a total rotation. Or I could talk about going -315 degrees in the other direction. Those two angles end up with the same terminal side. They both start with the same initial side. They both start on the positive x-axis. One goes clockwise, 315 degrees. One goes counterclockwise, 45 degrees. But those two angles end up in the same place. So -315 degrees and +45 degrees, those angles are coterminal. As another example, think about 90 degrees up here. 90 degrees is this point up on the positive y-axis. 90 degrees has to be coterminal to -270 degrees. So -270 degrees and 90 degrees are coterminal. So we can think about lots of examples of that, and we will, but before we talk about that more, let's talk about the radian measure, which is a different way of measuring the size of an angle. So you can see here I've drawn a terminal ray. Here's our terminal side. We're measuring from the positive x-axis. That's our initial side. And the angle then defined between them is here. And that angle, let's call it theta, can be described in radians, or, sorry, it can be described in degrees as before, or it can be described in this new angle called radians. Sorry, this new measure called radians. We define the radian to be one complete rotation is the distance you'd measure around the unit circle. I've drawn a unit circle here. We've got a circle of radius 1. The unit circle, remember, is literally just a circle of radius 1. And so the distance around that, the distance around a circle, the distance is just the circumference, and that's 2 pi times the radius, and the radius here is 1. So the distance around this unit circle is 2 pi, and we define that to be the angle measured in radians around that circle. So one complete rotation is 2 pi radians, and that means we can split the total thing up like we did before with degrees. If one complete rotation is 2 pi radians, that means starting from the initial side, the positive x-axis, and going one full rotation. That's 2 pi radians. Then a half of that rotation, well, that must be pi radians. A quarter of that rotation, up to the positive y-axis, that must be pi over 2 radians. Just a half of what we had here. If we go here, this was, if you like, 0 radians to begin with, and then we started measuring in the counterclockwise direction. Then we get to pi over 2 radians, and then pi radians. Down here we had a half, now we've got 1. This must be 3 pi over 2 radians, in other words, 1.5 pi. And here we've got 2 pi radians. And so we can measure angles in this way, well, in a way similar to we did before. That angle we had before, which was at 45 degrees, we could describe that, well, that's half the way to pi over 2 radians. So that's pi over 4 radians. Now, you should get used to using these basic angles. If this is pi over 4 radians, this is 2 pi over 4. Over here, we've got 3 pi over 4. Now we've got 4 pi over 4, that's just pi, and then we've got 5 pi over 4, and then 6 pi over 4, that's the same as 3 pi over 2, and then we've got over here, that's not a very good angle, but then we've got 7 pi over 4 radians, and the next one's 8 pi over 4, which is 2 pi. So we can split the unit circle up into these, or the angles up into these radian measures. On the previous picture, we saw that 3 pi over 4 radians was somewhere over here. This is 3 pi over 4 radians. And imagine you started here. We're talking about going 3/4 of the way to pi radians. Well, there's pi radians. And so I could also start at the same place, start on the initial side, the positive x-axis, and I could do one full rotation and then 3 pi over 4. In other words, one full rotation, well, that's 2 pi, and then another 3 pi over 4. Which, putting them all over 4, that's 8 pi over 4 plus another 3, that's 11 pi over 4. So that is coterminal to the original one. It's coterminal to 3 pi over 4. So we can do the same kind of calculations we did for degrees with radians. And we've got the idea of coterminal angles for these, just like we did with the angle measured in degrees. This is simply a different measure. We could do the same thing, if you like, by going around 2 full loops. So 2 pi, another 2 pi, and then 3 pi over 4. We end up at the same terminal side. So we're saying in this case 2 pi, and then another 2 pi, and then 3 pi over 4. Well, that takes us to, what does that take us to? This is 2 pi over 4, that's 8 pi, and there's 16, and then 17, 18, 19 pi over 4 radians. Is also coterminal to the other two. It's coterminal to 3 pi over 4. It's also coterminal to 11 pi over 4. All of those angles mark the same point. 19 pi over 4, 11 pi over 4, 3 pi over 4. They mark the same point. They're coterminal because they differ by 2 pi radians, or they differ by 360 degrees, if you want to think about it in terms of degrees. So if we have two ways to measure angles, if we've got an angle down here, and I'm usually going to call angles that we don't know the value of, we're going to call it the angle T down here. If we've got an angle T, then we've got two ways of measuring it. It obviously crosses the unit circle. This terminal side crosses the unit circle, so we can use the distance measured along the unit circle, which is just this distance here. That is literally the number of radians we have, that distance along the unit circle. That's the angle measure in radians. Or we could talk about it in degrees, which is the fraction of 360, the fraction of the total rotation we've done. And the key is the idea that 2 pi radians is one circle, one complete loop counterclockwise, and 360 degrees is one complete loop counterclockwise. So from this, we can very easily convert from one set of from one unit, radians, 2 degrees, or vice versa. So I can rewrite this expression very straightforwardly, just divide by 2 on both sides, and tell you that the same thing is, the equivalent thing is to say that pi radians is the same as 180 degrees. Pi radians is the distance from here to there around the unit circle, and this is 180 degrees, also known as pi radians. Okay, so let's use that to do an example. Let's convert 76 degrees into radians, and this angle maybe is 76 degrees because we know 90 up here is on the y-axis. So what I want to do is take my 76 degrees and convert it to radians. So I'm going to write out what I mean here. This is 76 degrees, and I'm going to use the units. I'm going to multiply by something here that fixes my units. I'm going to divide by degrees and multiply by radians, and that will give me the right units, right? Because then I can cancel the degree units and be left with just the radian units. Well, this thing has to be 1 essentially. Well, pi radians and 180 degrees are the same, so pi radians and 180 degrees, that ratio is not changing the angle, but it is changing the units. So this is 76 degrees divided by 180 degrees, that's the fraction of that half circle that we've gone, multiplied by pi radians, well that's what we would do for a half circle in radians. So multiplying this out gives us 76 pi over 180, and this is now in radians. And we can simplify that. We can cancel factors and things, but this is the angle's length, or the angle's measure in radians. So 76 degrees is the same as 76 pi over 180 radians. Okay, so let's do another example. Let's convert 1 radian into degrees. So here's our unit circle. If you think about 1 radian, well this is pi radians. From here all the way up to there, counterclockwise, is pi radians, and that's 3.14. So about a third of that way would be 1 radian. This is 1 radian. Right, there's nothing special about pi here. This is just the irrational number, 3.14, and so on. So if I say 1 radian, we're talking about an angle which is, about a third of that way, a little under a third of the way from here to there. And so I want to convert it into degrees. Well, we use the same idea as before. 1 radian, I'm going to take my 1 radian and I'm going to multiply it by a quantity that cancels out the radians and adds in the units of degrees. And that ratio is given up here. So that ratio is, we know 180 degrees, this is the same as pi radians. So multiplying by that quantity, the radian units cancel and we're left with 180 over pi, and this is in degrees. So if you get a calculator out, this is 180 divided by 3.14, whatever that is, we could approximate the value. So there's examples on how to convert between these two units. All right, before we actually define our trig functions, we need a few other terms for angles. Complementary angles are 2 angles that sum to pi over 2 radians, or 90 degrees. So for example, on this picture, if I took the angle here, let's call that theta, and I took the angle here, which is phi, those 2 angles add to 90 degrees or pi over 2 radians. And so those 2 angles are what you would call complementary, because when I add them together, we get 90 degrees or pi over 2 radians. Alternatively, we can talk about the idea of supplementary angles, and those are 2 angles that add up to 180 degrees or pi radians. So if we take this angle theta again, the same angle we had before, and instead of the angle I drew last time, let's draw this angle in. If I took those 2 angles, theta, and let's call this psi maybe, if I take those 2 angles, then they would be supplementary because they add to pi radians, or 180 degrees. So there's the idea of supplementary and complementary angles, and we'll explore them some more. A couple of other ideas that I'm sure you have encountered before. The idea of acute angles, that's just when I'm saying the angle is less than pi over 2. So if I took this down here for the initial side, then the angle pi over 2 would be making a right angle there. And so the angle I've marked here between this initial side and the terminal side is less than that, less than 90 degrees, and so that's called an acute angle. A right angle, I just use that term. It's a term where the angle between the initial and the terminal side is precisely 90 degrees, precisely pi over 2 radians. And we're going to be using radians most of the time, so you're going to need to get used to them. In this case, if I mark in the right angle here with the initial side, thinking of this as the initial side, because we always measure counterclockwise, then an obtuse angle is an angle that's bigger than 90 degrees. So this terminal side creates an angle that's more than you would get if you looked at the right angle here. All right, so one more thing we've been skipping around while we've been talking about radians is the idea of arc length. So let's just finish with that. So finally, to calculate the arc length, so we want the length I've marked in purple along here. So the length along the circle of radius r, but subtended by an angle theta. So inside this little chunk that's cut out by the angle theta. So we know precisely because this radius is defined from the unit circle, we can say that we've taken a fraction of the unit circle. What fraction? Well, we've taken the fraction theta out of the possible 2 pi radians. So I'm imagining theta here is measured in radians. And if I took the entire circle, if I went the entire 360 degrees in degrees, or 2 pi radians in radians, then I'd get 2 pi. But I've only gone this distance theta. So the fraction of the total circle I've got is theta out of 2 pi. And the total length around this circle, this is a circle of radius r, so the total length around this circle would be 2 pi r. And so multiplying those together, this is the fraction of the total circle we have, and this is the length of the total circle. Multiplying those things together, you can see that the 2 pi's cancel, and what we're left with is just theta r. And this is the arc length, we'll call it s. This is the arc length around the circle, where r is measured in radians, where theta is measured in radians, and r is the length. And then s is the length subtended here, this piece of the circle. So that's our final kind of equation or idea coming from these definitions of angles. Next time, we'll talk about defining the trig functions. So have a go at the pre-class exercises, and I'll see you soon.